It's Wednesday, the night before Thanksgiving. I hope everyone's having a good week so far. I think for the United States, it'll be Thanksgiving tomorrow, so I hope everyone has a wonderful Thanksgiving. We'll continue where we left off for this particular project, which is definitely not Centipede and JavaScript and using the JavaScript P5 library. So far, let's go over a quick review of what we've done. I've also done some modifications over in between. I was just kind of inspired. So let's open in a browser. Let's open in Chrome. Let's take a quick drink though. All right. So here's what we have so far. We got our mouse movement. We have our bullet behavior. We have the pseudo mushrooms. They're just red blocks for right now. So we have our little ship. We have our bullets. We added the mushrooms. We created the centipede so it moves down the screen. We have added in the collision behavior so it bounces off of the little mushrooms here, or what would be mushrooms, and moves down the screen. It looks like, though, we have some minor adjustments to make to the centipede, though, so that it doesn't bunch up. So let's go ahead and make some of those modifications and kind of go from there. So where were we? We were over here at Centipede. So I think part of the collision issue is coming from this bounce approach. I had given a bounce compensation of 1, but let's see what happens when we do 2. And let's see how that behaves. Seems to be alright up here, I think, once we hit this area here. Nope, we're still good. So it looks pretty good right now with that bounce compensation. And the bounce compensation simply says when it hits a block to go down to the next line. And I found a way to move the mushrooms into kind of a grid-like behavior. So it generates the mushrooms and puts them inside of a grid. And then yep, cool. So we're going to add, the behavior that we're going to add today is have it so that when the centipede hits the bottom of the screen, it will bounce back up and kind of stay within one area. Now, one of the things that I noticed in the system is that in the original design is that it just kind of stays in the bottom after that. So we'll come over here and guess we need to create a bottom handler so that when it hits the bottom, this is the collision handler, and boundary collision handler. Yeah, so this moves down. I think we need to change this so that it moves back up. So I think we'll do a move up functionality. We'll do the following. We'll say that when a particular piece hits the bottom, we need a flag to say this dot hit bottom, and it'll be equal to false by default. So that way when it hits the bottom, we'll go ahead and say that it did, and then we have to move up and down within a range. So we've collided with mushroom, that handles that. We've collided with edge, and so this handles the left and the right, but it doesn't handle the bottom. So I think this is going to be, we'll make it a separate function, collided with bottom And then from here, yeah, once we have hit the bottom, we need to create kind of, we'll call it collided with top. And this will only come into play when that happens. Enable move vertically. So we'll call you enable move vertically, and we'll pass in the function that we want to do. So this allow move, we'll change it from allow move down to allow move vertically. So this dot allow move vertically. If this allow move vertically, if this allow move vertically, if this allow move vertically, and we'll shortcut you to Fn. And instead of move down, it will be determined by this other functionality. So we'll need to add directions for down and up. So we'll create right. We'll do a down here. And we'll do an up here. So we need to come back over here to the Centipede. And we need to change you from direction to horizontal direction, and this dot vertical direction is going to be equal to directions dot down. So then we'll change you to just horizontal direction. If this dot horizontal direction, this dot horizontal direction, find this dot direction. Yep, here it is again. And let's see, do we have any other? This dot direction is equal to, yep, that takes care of all the places where we do direction. And now we have to do the move down. So the vertical direction is going to be down for right now. And if this allow move vertically, we determine whether it's moved down or not. So this dot move down, and we needed this dot move up. Move up is going to be equal to the same thing. And I guess we could call it move vertically. So vertically, and we'll say this is going to be equal to plus equal the same thing. So we'll go this dot vertical direction is equal to directions dot down. Then it's going to be similar to above. This should be move horizontally. Horizontally. There it goes. Broke a bunch of stuff. So math.absolute velocity, and our velocity in this particular case is wait, what is our velocity? We don't have a velocity. Move horizontally. Where's our move functionality? Start move. New speed. Oh, that's right. We allowed for the speed to be variable, but for the move down and move up, it should be consistent. This dot vertical move is going to be equal to 10. So we'll just come down here and say move vertically. This dot vertical move. Otherwise, we do the opposite, plus equal. Yep, here we go. So Cool. So that still breaks a bunch of stuff. When do we do this dot move? Oops, that's not right. This dot move. This dot move horizontally. You handle that. So you're good. So that moves you horizontally. And what we don't have handled is the move down. So this dot allow movement vertically. We have to determine whether we're going to move down or move up. So we should just do this dot move vertically. This dot move. This dot disable move vertically as well. And our movement is back. Cool. So it's cool. So all right, this dot hit bottom is equal to false. So we need to add in our edge case. Collided with edge, collided with bottom. So we'll get the bottom. How do we know what the bottom is? Base horizontal margin. I think for the bottom, when we look at the game, let's take a look. It's the bottom base margin. When we create our border, where do we limit our ship to? So let's take a look. And our ship, this right margin, calculate horizontal, vertical. Nope, this isn't quite right. Vertical position. This dot canvas size minus base bottom margin. Base bottom margin is, where is it in our game? Base bottom margin. When we create our ship, we create it up here. Its base bottom margin is 30. So it's gonna go over here to our config. We have a base, and you're gonna also be the export const base vertical margin. It's going to be equal to 30 as well. And so then we come back over here to Centipede, and we say collided with bottom is const bottom margin is going to be equal to, since it's plus, it's going to be equal to canvas size minus that. And we'll just say if this dot vector dot y is greater than or equal to the bottom margin, we will turn this dot hit bottom equals true, and then we change direction. So we then say this dot vertical direction is going to be equal to directions dot up. So when we bounce off the bottom, collide with bottom, where do we run our collide with edge? This dot collide with edge. I think we run it. Yep, we run it in here. So this dot pieces. We'll put it down here. So we'll say this dot pieces I dot collide with bottom. And then we have one more thing to run. So once that's enabled, we trap it just within a small area. So we would say, what is it going to be? I guess we just trap it within the 320 area. So our ship, come back over to ship, and how do we determine that? Max Y, top margin, is going to be equal to canvas size divided by 4. So we'll use that same calculation here in Centipede. So const top margin after hit bottom is going to be equal to canvas size divided by 4, 3, and we're going to say once it hits it, hit bottom is still equal true. So if we didn't hit this dot bottom, we can just exit. Otherwise, we have to just keep bouncing it back and forth. So we would say this dot vertical direction is equal to directions dot down. And we'll change collided with top so that you run with these. So this dot pieces I dot collided with top. And we'll just bring it back over here. So let's take a look at how that looks. Take a drink in the meantime. So so we have our pieces. This time around, what I'll also do is have it so that the mushrooms are destroyed little by little rather than all at once. And let's see whether this bottom behavior works the way we want it to. So we'll hit the bottom shortly, and then let's see what we do. Maybe we'll hit the bottom shortly. Yep, then we start moving back up, but we start moving back down again. We move back up. Oh, hold on. I see. And then what? So I think my math is off here in my centipede piece. So if we have to limit the top. So if this dot hit bottom, oh, we just say vertical down. We didn't check. So we need to say if this dot vector dot y is less than or equal to our new top margin after hitting bottom, then we change direction. Paste it back here. So it winds its way back up, and we'll test that out in a moment. So this is handling our centipede. Let's do the mushroom piece first. So we'll have it so that when it bullet collides, where are we using you? Bullet collided. And I think we're doing it over here in our mushroom helper. We grab the collided bullet, and we need to redraw the mushroom. While we do that, we'll keep watching it. But I think, yeah, we'll have it redraw the mushroom. So what we'll do is after it gets hit, if this dot current, we need to take the x of the mushroom. No, the y. Yeah, we need to take the y of the mushroom and redraw it. Current mushroom. So we have our centipede. It moves towards the bottom. It seems to be doing just fine. I'm kind of happy with the fact that we're using grid now. It also keeps our mushrooms from overlapping each other, which is nice. And here it goes, working its way back up, which is what we want. And it's going to hit our wall soon. Let's see if it behaves. Yep. And then it moves down again. Cool. So our Centipede is working the way that we want it to. So now we need to create kind of a hit system for each individual mushroom. So we have a mushroom. We created a hit point system for it. So we want to take it up instead of 2. Let's make you 4. And it's going to be a little awkward though because it's not an even number. But I don't know if we really care that much. So for the first hit, we'll take off, what is that? 10 divided by 4. We'll take off 2.5. So yeah, display bullet collided. Display this dot R. Let's see what this rectangle is equal to. Width, the height, this dot R. So we'll do a on hit, and it'll be equal to this. So when we get hit, we'll take this dot hit point minus equal 1. And we'll say, what do we want to say? And then we want to return our hit points. So, actually, return true or false. So we'll do this. If this dot hit points is less than or equal to 0, then return false. And what we're going to do after we return false on hit, it deletes it. But otherwise, we're going to resize the mushroom vertically. So we want to we actually want to separate this out. So we want to say this dot width and this dot height. And again, I think I'll have to play around with these so they're not just kind of magic numbers hanging out here. But I guess they're not magic numbers since we've put them up here. So this dot W, this dot H. Let me check something. As I think, yeah, we need to see all the other places that we use. Ooh, that doesn't look good. We need to check all the other places where we use .r for the mushroom. We don't use it here. Actually, we'll just do a quick search through the whole thing. So we'll do a .r. No, not a good idea. We'll just look in the internal library. .r. So this dot collided circle, this dot width, this dot height. So that takes care of you. And for the centipede, we need to fix you as well. So let's come over here. And for the mushroom, it's not mushroom.r, it's mushroom width and mushroom height. And we add bounce compensation to this. Let's see if we remove you, whether you behave the way that we want you to. So let's take a look at that. So here we have our centipede moving across the screen. No collisions yet. Bounce, that's pretty good. Bounce, that seems okay. Bounce, all right. So you're good. I think the only place we're missing it is within the ship information. So we got the centipede moving down the screen. We need to deal with the collisions on the ship. So this is the centipede. Let's actually just look for all the places that I reference mushroom dot, because I tried to keep it mushroom dot ID display XY XY Yep, there's the remaining spots. Mushroom.r. It's all in ship.js. So let's fix you. Minus mushroom for the left boundary. We want to use the mushroom width. Same thing over here, because the mushroom height is going to change. And then, and if we were to use TypeScript, this would be even easier because it would help us. I think we can add in some pieces to that. It's not quite right, but we'll see what we can do. So it's still drawing the mushrooms correctly. We still have our collisions behaving correctly for the centipede. What we are lacking is the collision handling here. Let's take a look. So current mushroom Y and the current mushroom height. I think it has to do with this. Maybe. On hit. Why aren't you hitting ship? Why aren't you colliding? If collided with mushroom, let's check it. This dot collided with object. Add to this dot r. And this should probably be collided with square object. So let's see how that behaves. No. Nope. Oh, I see why. It's not this dot r. It's object dot height and width. And now we have our collision back for the ship. Cool. It's a little jumpy, but we want to fix that later on. So we have our collisions behaving correctly for the centipede. It bounces as it moves down the screen. And we have our collisions back for the ship. We were having it so that when you shot at a mushroom, it only deleted part of it. So when we shoot down the ship, or shoot at a mushroom, we slowly reduce the hit points. And when it hits 0, it returns false. And we want to resize the mushroom vertically when it's hit. So we want to take this dot height minus equal 2.5. And that's just going to be equal to this dot height divided by this dot hit point. And it should subtract that, and we'll do this. So we have our mushroom helper over here. We determine if it's collided. So it collided with a bullet, and we don't remove it yet. We now have to determine, we have to reduce its hit point. If it's collided, we say the current mushroom, we'll create a const. We'll ask if the mushroom survived. Mushroom survived is what we'll call it, is going to be equal to whether the current mushroom on hit, what will it do? It will take the hit points down by 1, and we could, I guess, really wrap it inside of a if the mushroom survived. Oh, I have to return something. Pfft, look at me being an idiot. Return true. If the mushroom survived, and actually, we'll do this. We'll call it survived hit. Mushroom.survived hit. Yeah. So we'll ask the question, if current mushroom.survived hit, then it returns true. And we don't do anything. I think it'd be easier. Did not survive hit? Let's do that. We'll change it to a true and then a false. So yeah, so we'll do that instead. So if the mushroom did not survive the hit, we remove it. Otherwise, we just say the bullets just disappeared. Let's see what that looks like. So we'll nice. Oh, it disappears, but not quite. So let's try that again. 1, 2, 3. There's still a piece there. So, but it's just a tiny sliver, but we want it to equal 0. So I think we need to make the chunks bigger. Oh, but do we? So we still want the hit points. Oh, less than or equal to 1. Let's just do that. Yeah, that'll work. So we'll come back over here. Hit, hit, hit. There we go. 1, 2, 3. And we could up that, but then we would take way less. So we could just say 2. And then change it back to 0 and see what happens. 1, 2, 3, 4. Yep, 1, 2, 3, 4. Nice. So we now have it behaving a bit more. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3. That felt like 5. So let's do that. Yeah, let's leave it at less than or equal to. Guess we could change you. Let's see what 2.5 does. It really doesn't kind of matter past a point. I think that looks a little bit better. So yeah, you can delete the mushrooms. Let's see whether we can, if we kill the mushrooms before it hits it, what'll happen. I think it's going to hit you. Nice. Cool. So now it won't bounce off of mushrooms that we've killed. It'll just keep going down the screen, which mimics what we wanted for our definitely not Centipede game. I'm going to change the name, by the way. So it's definitely not, Centipede. Real big change there, right? Anyway, where were we? So we've collided. We have our collision. We have our behavior. The only thing we need to do now is start working on having it so that when you shoot at the centipede, it actually destroys pieces of the centipede. Because we have it moving down the screen. And then from there, we'll start working on things like scores. And actually, what do we want to do? So bullets should be fine. We could actually add the random insect, but I think that's going to be a whole ball of wax in and of itself. Let's also make sure that our collisions down at the bottom still work. So it bounces down here. It hits bottom and then moves its way back up, which is what we want. So, and then if we destroy, yep, cool. So it'll bounce up, hit'll top limit, and then bounce, start moving back down. What do we want to tackle next? So we have our grid, we have our centipede. We have it so that you destroy little bits of the mushrooms as you go. What do I want to work on next? I think the next piece should be, why am I kind of blanking on this? All right, so mushroom collisions. We'll pause on. Let's do what happens when you get hit by a bullet, when the centipede gets hit by a bullet. So we have our centipede, our class up here for it. We don't really care about whether it's the head or not. But what we do want to do is we don't care whether it's the head or not. We'll grab the centipede piece, and I don't even know why we bothered to do this. Yeah, we don't really need to know whether it's the head or not. We just create the first item and all the pieces after it. So we start it X and subtract the pieces. So let's delete you and just create pieces. And we'll call it create centipede pieces. Well, we're already in the centipede class, so like there's no need for a separate head. This dot offset start X. There's no minimum piece. We just go to the length, and we start here. If this dot length is less than the minimum piece, this dot length is equal to this dot minimum piece, and the minimum piece should be 1. So it'll always have at least 1. We will call this create pieces and replace you. No longer need create head. You'll just create the number of the centipede pieces. And now we need to handle, I guess, bullet interactions. Create mushroom collision. And then we need to handle bullet collision. So handle bullet collision. And we need to pass in the list of mushrooms. Or, sorry, the list of bullets. The list of mushrooms. Oh, man. So we'll handle it similar to the mushrooms, where we handle bullet collisions. So we'll say that the collided bullets is here, because once it hits, the collided bullets have to go away, and the piece has to go away. And then it needs to take one piece. Ooh, this is going to be a pain. So if you hit the head, the pieces behind it all need to change direction. So if you hit the middle, the pieces behind that middle piece all change direction. All right, let's try and figure this out. If we'll add a similar if statement to this. So if there's no bullets, we don't return anything, and we don't do anything either. We need to loop through the number of bullets, get the current bullet, and then we have to figure out if it collided. So we then need to look through each of the current pieces. Now, so the bullets are moving and the centipede is moving. So I don't have to worry about this math. Something already does it for me. Yay! Collided rectangle. No. Bullets are round? They're get bullet. I'm not using your ellipses. So for those who don't know, P5 has a collision class, a collision library, and again, thanks to whoever made it, Mr. B. Morin, Ben Morin, thank you very much for that. But there's a bunch of pre-existing pieces in here. So you can collide ellipse, or we could collide circles on circles, which is what we're going to do, because the centipede's a circle. So mouse Y, radius, cool. So ellipse. Yeah, because we don't have, well, it does say circle. Let's look for the ellipse. Ellipse. Point to ellipse. Ellipse. Point to ellipse. but I think we're gonna do circle, and we'll call it, we'll do circle to circle. So I'll come back over here to our centipede, and we have the current bullet, and we need to loop through all the centipede pieces. So we'll do the same thing here. We'll grab you. We don't want to use I again. We already used I, so we'll say X, 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 X. The bullets, and then I is for the centipede pieces. And we'll loop through all of those, and we'll create another thing. So we'll say if we'll call you a const here, const current centipede piece is equal to this dot pieces I in this particular instance. We'll give ourselves some space here. And so if the current piece collided with a bullet, we need to compensate and figure out what to do with all of its sisters and brothers. So we did give each piece an ID. We did. But we didn't give them an order. So let's give them an order. Yeah, let's give them an order. And it's going to be equal to whatever we pass in. So it'll be static once it's set. Will it? Yeah, it'll be static once it's set. So then when our constructor goes, let's take a look. When we create the centipede, we create the vector, and we need to create an order. And we'll call it X. Yep, so whatever the for loop is going to do. So that way we can figure out what the order is. And when that one is hit, we need to find the order +1 and the order -1 and change their directions, and all the ones after it as well. So you loop through all the pieces. You need to destroy the current piece. If current centipede dot, and we'll do the same thing here. Survived. Did not survive the hit. Did not survive hit. We need to remove you. So we'll pseudocode for right now. Remove this piece. And I guess we should split the array. Remove the piece. Oh, are there any more centipede pieces? If there's none, then there's nothing else to do. Get all the pieces after this one. After this one. Get all the pieces before this one. Change their direction, and they'll just continue to keep going. And change their direction. And how do we change their direction? We're going to have to trigger it. We are going to have to say this dot will trigger the boundary. So we need a couple of things. So let's come up here. Let's add the did not survive equals did not survive hit. And we actually need to know the bullet information. we actually need to pass in the bullet. Yeah, did not survive hit for the current bullet. And so, well, let's take a look again. Rectangle, circle, circle. So we want circle, circle. Yeah. So we want collide, circle, circle. Return, collide, circle, circle. And we want, yeah, this dot x dot y. We want the vector position and its diameter. So this dot vector y, this dot diameter, and we want the bullet. Oh, hold on. We need to make it a property or parameter. So bullet dot. Hold on. Where's our bullets? Bullet helper. Yeah, there it is. We want to get bullet. Bullet.get bullet. It's one of the few times we want it. Then it just simplifies the X and the Y and the ID. So, yep. So yeah, we'll do it down here. So we'll say handle bullet collision did not survive hit for the bullet dot get bullet, and that just returns us a cleaner object with just the X and the Y and the diameter. We'll check that over here in bullet.ds. Yeah, X, Y, and the R. So then we come back up here and we say bullet dot X, bullet dot Y, and the bullet dot R. Simple. Well, simple-ish. So it did not survive hit if it returns true. So it didn't survive the hit. We got to remove this piece. So we should splice it. Yeah. This dot pieces dot splice. Do we know its position in the array? We do. We can find it. So we can find it by going, we'll call it const dead piece index is going to be equal to this dot pieces. Well, actually, we have it already. Yeah, because we have it here. So if it did splice, this is going to be equal to start. We'll start at I and 1. So we'll splice it there. And let's check to see if there's any more Centipede pieces. If this dot pieces this dot pieces dot length is equal to 0, just return. There's nothing else to do here. We're done. So let's see if this all works, and then get all the pieces after this one. So we need to stop looping at this point because we've hit, so we have to do other things. So I just don't remember off the top of my head, JavaScript breakout of for loop. I think it's just break. Yeah, it's break. So let's see if this piece is, yeah, we want to get out, just break. And I guess, yeah, we want to stop. Maybe. We'll see. If there are any more pieces, yeah, I'm trying to kind of draw a blank here. Get all the pieces after this one, change the directions. So we should get from this position forward and this position behind you. Const before pieces is going to be equal to this dot pieces dot I guess we want to get all those pieces. I guess we splice and we have a starting position and we want to go before the pieces. So it's going to be 0, start number 0 to whatever I is equal to. That's the before pieces. And the const the after pieces is going to be equal to this dot pieces, and we want to start at I and go to this dot pieces dot length minus 1. And so that will give us the after pieces, and we want to loop through and change all of those. And so we will create a second handler over here called handle subpiece direction change. And here are our pieces. And ooh, you know what we should actually do? We should break them off into their own unique centipede. That's what we should do. So we need to know we should just create a new centipede at that point. Yes. Let's create a new centipede. How do we want to handle that? We should probably return a more complex object. We should probably return a more complex object. If there's no more pieces, just return nothing. If we, let's go back to our game, because we have centipedes. So centipedes equal create, and we'll let it be an array. So we'll start here, and we'll start with just 1 equals new centipedes.push 1 new centipede. And so then what we'll do is we'll return. So then we come down here to centipedes. We'll do the same thing. Centipedes dot for each single centipede, and we will say loop through and run and display them all. Centipede, nope, single centipede dot run, and single centipede dot handle mushroom collision. Now this is starting to get, I think, a little complex, but I think we're okay. So we handle our mushroom collisions here. Let's see. Nope, you broke a bunch of stuff. Well, I broke a bunch of stuff. Ship is undefined. Ship is undefined? Where? What? The game. Mouse. Ship. Did I mess up ship? No. Mushrooms. Centipedes dot push. Ship is undefined on line 75. Mouse pressed. Why are you undefined? I broke something. I had to have broken something. For each. Yep, I had to have broken something. Pieces is not defined. Handle, subpieces change. Yeah. So, what we need to do from this point is to get the X's and Y's. And I guess when we create a new centipede, we should allow people to pick a direction. Doesn't it? Or will it just... No. We should allow people to pick a direction? Let's just create them for now and go from there. And all we need is the first pieces, X. So, when we do break one, if there are any more pieces, we need to get the before pieces. So let's try to get const. The before piece is going to be equal to this dot pieces. The before is I minus 1. And the after piece is going to be pieces I plus 1. What if they don't exist? Let's handle it down here. We're going to return an element. We're going to say return, we'll call them just new centipedes. New centipedes. I'm messing up on my spelling. New centipedes is going to be equal to just we'll add in the centerpieces. So yeah, how do we want to do this? We'll push in a single piece. So we'll say if it exists. Otherwise, we'll say it's an empty, and we'll use ternary statement. This dot piece is plus 1. Otherwise, empty. That's wrong. It's a ternary, so it should be a colon. And then we'll say down here, concatenate before pieces and after piece. Dot dot after piece. I guess there's not a need to return it like this. Yeah. So colon. Yeah. And no need for you. No need for you. And we need to return the bullets. So we can't break. We have to remove the bullets too. Handle bullet collision. Yep. So we come back over here to Centipede. And we don't need this piece. We don't need to determine if the pieces are 0. If it's hit, we return new centipedes, and we return collided bullets. Which is just one thing? Yeah, I guess because it's going to be... Well, it loops through for each of the bullets. I am struggling with how I want to do this. So... we'll say collided bullet, and it's going to be equal to the current bullet .id. We'll see how this all comes together, because I think, yeah, we'll see how it comes together, because I think this might be going to repeating too often. So let's come back here over to here, And for each single centipede, you'll loop through and const centipede bullet data is going to be equal to single centipede dot handle bullet collision, and we'll call bullet handler dot get bullets. Yeah, that's what we called it. Dot get bullets. Cool. So we get all the bullets, and we'll call you remove bullet handler dot remove collided bullets. Now what it's returning for them is an array. Remove collided bullets, and it's going to be the centipede bullet data dot collided bullet as an array. Let's see if this works. And then we need to grab any of the pieces. And then we need to create more centipedes. And I kind of want to put you somewhere, but I don't know where. Because this is a single centipede. Maybe I need a centipede helper. Let's just put it here for right now. Get the pieces and make new centipedes. So let's find our bullet. So we'll do a second for each. Yeah, so centipede bullet data dot, what did we call you? New centipedes dot new centipedes dot for each. There's a lot of looping in here. New cent to pede, and we need to grab the X and the Y for you. So let's go back to our centipede. We need to get this dot vector dot x dot y, and so for here, this could spiral out of control very quickly. This dot x dot for each const. Oh, and we don't even know how long it's supposed to be, so I guess we do need that additional information. I forgot about that. So we create a new centipede start x start y. Centipede start x. We'll start to figure out the x and the y. We'll keep the speed the same, but we do need the length. So and we need to know how many pieces are before and after. So 4 piece after piece. Yeah, let's make this more complex. New centipedes is going to be equal to it's going to be equal to an object. Why don't we make it an array of objects? So and that is going to consist of, let's make you up here, const new centipedes is going to be equal to, let's make if statements. If this dot pieces I minus 1. So we have it. We'll start off here. If it exists, new centipedes dot push. We need to create 1 at start piece. Yeah, we'll call it the start is going to be equal to this dot. If it's there, yeah, well, it's that piece, and the length is going to be equal to this dot pieces. So we need to know dot. So we want to splice you. Start. No, we want dot slice. Start number is I, and we want to go to the end minus 1. No. We want to go to the front. So the end number 0. How do we slice forward in JavaScript? Because I don't do it often enough. Slice forward. Yeah, slice. So if we want ant and bison, we go negative. So if we start at 2 and we want, yeah. So if we want the negative, we want duck and elephant. That's minus 2. So 2 to 4 would give us camel and duck. Let's read. Start 0 is used. So we want to go from 0 to I. Yeah, that's where we want to go. We want to go from 0 to I. And then we want to go. Oh man, something in my eye. So dot length. And we'll do the same thing here. If this dot pieces I plus 1. And I feel like this is sloppy. So this is equal to I plus 1. And you want to start at I. And you want to go to, give me a moment. I need to work my eye. And we want to go to this dot pieces. Oh, we want to go to the length. So we want to go to the end. If end negative counts backwards. If end is less, causing all elements until the end. So we'll just exclude it. So and then return Centipedes. Okay, so then we come back here. Yeah, we come back here. We loop through each of the new centipedes. Const new, and then we say centipedes dot push. We push into new items. Yeah, we do centipedes dot push new centipede. The start's going to be equal to const new x const new y is going to be equal to the new centipede dot new centipede dot start, and that's going to be equal to a single piece. So we want start dot vector vector dot x, and it's going to be the same thing, which are going to be y instead. So much involved in this y. So new start is going to be the new x, new y, speed of 2, and the length is going to be equal to new centipede dot length. Yeah, new centipede dot length. Let's see how much of a mess this is going to cause. Yeah, let's see what stuff we break. I think I have it around here somewhere. Yep, we've broken a bunch of stuff. So let's see what we've broken. Pieces is not defined on handle pieces. Oh, I left some code in here. That's why. Yep, don't need you anymore. I think. Nope. Centipede is undefined. I did undefine you, didn't I? New centipede, new centipede. Centipede data. New centipedes? New centipedes? No? Centipedes. Let's take a look. Const centipede bullet data. Guess I could put a question mark here. But you shouldn't. Remove the collided bullets. I guess we should add a check in here. If centipede bullet data dot new centipedes, if it's there, and dot length is greater than what? Dot length is greater than 0. It's the only time we want to run this. So you move down. Ugh, didn't work. Nope, you missed. Nope, you definitely hit. So let's put some breakpoints in here and see what's going on. Handle bullet collisions. So here. Handle bullet collisions. Let's put a debugger in here. Yep. Debugger. Okay. You're not being hit at all. I think it's due to if this dot mushroom or if this dot pieces, or yeah, it's my fault. I exited early and I have it returning the collided bullets with nothing else. So I need to return this fancy object here, which would be the collided bullets of nothing. And new centipedes is equal to an empty array. Okay, so that hits our debugger statement. Cool. So we know that part works. Let's go ahead and remove the debugger, and let's. Ooh, we've killed it. We've killed it. Centipede bullet data is equal to undefined. So we messed up. I messed up. So we get the data. And ultimately we could break it up to handle the bullets and then handle the pieces separately. So, but what we want to do is let's do this instead. If centipede bullet data and centipede bullet data dot collided bullet. We'll do two if statements. And again, I think ultimately the handler. Oh, we've frozen again. Centipede bullet data is undefined. Oh, that's what I did. I didn't do this. And I think we could say this instead. Centipede $? Question mark $? Question mark. So and then we could do the same thing up here. $? Question mark. So let's see if we can actually hit anything. Well, that's not great. Well, we have a collision though. Oof. And so, well, we have it dividing, but it's not grabbing the right amount. So let's put a breakpoint in here. So let's put a breakpoint in here so that we can figure out what's going on, but we're not horribly off. In the meantime, let's actually kill the mushrooms for right now. Let's go to our game. Let's make one mushroom. That's one. So we can focus on hitting the centipede. So let's take a look at our debugger over here. Let's bring it back. Pieces. 7. So let's see. Hit here. Step, 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 length of 2. So you're going to create one with a length of 2. That's fine. Ooh, that's not right. So that means I've done something wrong again. Speed. Start-wise speed length. It should have been 2. Let's refresh that again. I equals 8 to 10. Oh, did I mess that up in my centipede creation? I think I did. So let's check out my centipede creation. The length. And then when we say create, move, draw, create pieces. X less than this dot length. So that should be fine. So we're here. If let's see, slice 6, and let's see, your length is equal to 3. So when we get here, Centipedes has 2 pieces. Let's go up here and take a look. Let's move you down a little bit. New Centipedes. Length 6 and 3. So you are correct. And then when we create you in game, so the problem might lie in here. Centipedes.push. We create a new centipede with an X. And new centipede. Let's take a look at something. Nope, length of 3. So let's step over, step out. We get rid of the bullet. So we have that unique ID. We do have the data. We do have centipedes and the length. Step over. Step over. New centipedes? What? I thought we had you. Wait, what? What? What just happened here? What? Okay. So let's see what's going on here. Something fucked up. All right, let's see. Clean up you. Clean up you. Let's play. Let's put you back and refresh you. Sorry, we don't want that if statement running all the time. We only want it here. Okay. Put a breakpoint here. New centipede. Start. Okay. We get you, we get that position. That's fine. Length could be 8. And so then the only question is what's going on over here in centipede. So when we create you, this dot create pieces, if this dot length is less than new centipede diameter vector order, so let's put a breakpoint in centipede to see what's going on, because we should be here in centipede piece. We should be here in our create pieces. So let's play you. This dot start x, which is fine. The length is 8, less than length that 8. So did you make an 8-piecer? It doesn't look like 8 pieces. Oh, it's 11 pieces, isn't it? Yeah, it is. So length -1. Is that right? Let's take out you. Take out you. Why is there so much space between you guys? I see that it deleted 1. But why is there a space? Oh! It should create 2 new ones and delete the old one. That's right. That's what I'm missing. So let's use a for loop, knowing that I'm going to delete you. Because when you get hit, what you're going to do is let's use a for loop. So you're going to get our centipede data. We'll do a for loop. For let x equal 1. Yeah, we'll start at 0. X less than centipedes dot length. x plus plus. We'll call you const single centipede. Single centipede is equal to centipedes x. And then we'll pretty much run the same thing. Take out our for each. And if we get data, if we have this collided, if this is all that, we need to get rid of the other centipedes. We get all that data, we create new ones, and we take the current single centipede and we need to pop you off. Dot. Oh, we could just slice it. Dot slice. And for our slice, because we just did this, number and 1. So x 1. Let's see if that works. It does not. It is grumpy about that. All right, let's take a look. Centipede. Oh, I know why. We need to take centipedes that slice. There we go. So we hit you. You kind of created a new one, but you didn't change direction. So what happened there? Oh, yeah, they hit you just right. Bad at this. Kind of what we wanted. Kind of what we wanted. We need to we slice off. If it gets hit and there are new centipedes, we slice off, but we're not doing something. Or are we? I think it hit it right in the center. Let's put a breakpoint back in here and see. I think what's going on is we're not properly deleting. So, debugger. I want to see how many centipedes there are after I hit one. Yeah. Actually, we'll put you down here. So we start you, and centipedes 3. And what is x equal to 0? So we'll step over. Centipedes is still equal to 3. It didn't slice you at all. Start at 0, go 1. Why didn't you? 1 is a length of 3, 1 is a length of 5, and still 1 is still a length of 10. So it's not popping you off. So we'll start back up here at our for loop play. Nope. We will slice, then break. I think that might work. So we'll slice you, we'll break you, then it'll start over again anyway. So hit. Nope, still not right. Still not right. So put a breakpoint here. Let's refresh you. And let's see, hit. It should have sliced it. the length of 2 name slice. I must be using it wrong. It has to be it. I must be using it wrong. Slice. Start. Start is less than 0. You start. So if 1 is used, so by the time we get to here, let's refresh you and see what's going on. So when we get to here, Centipede is equal to 10, but slice isn't working. Oh, I know why. I am not resetting the value. I need to do the slice equals, and I keep clicking on the wrong thing. So it slices it off and sets it back. And hold on, let me double check. I think I used slice somewhere else and it's wrong too. So Centipede slice. Yeah, it returns. Yeah, that's what I did wrong. Yep, look at me being an idiot again. So we would say centipedes is going to be equal to slice. And so when we come back over here, shoot. And now it made 2. Fire again. And that works, but it isn't changing direction. So that looks like the only thing we have left. And do we want random direction? No, we want to get we length. And so when we do create a centipede, let's do this. Trigger direction change. This create pieces dot trigger direction change. Switch directions equals false. So when we pass water, switch directions. So let's come back up here. There's so many variables. Switch direction equals false. And then when if switch direction is true, then switch direction, if it's valid, then direction, we take the current direction, this dot horizontal direction dot what is switch direction. When we switch directions, then we take the current, and because whenever we start, it's going to be equal to whatever direction it's currently going. So we should just take the current direction. We should say we should accept a custom direction. And we just set it to this custom direction. And so when we, in Centipede, when we hit and create this piece, we do have its direction. So we need to come back up here And we can say custom direction, and it's going to be equal to U. So custom direction and create pieces custom directions are equal to U. And so when we create you, you'll pass in a custom direction if applicable. So in our game, we have, we're missing something. Yep. And I want to spend some time revisiting this and refactoring this. So we grab the centipede, const new direction is going to be equal to, we're going to get the new centipede dot start dot so many things to remember, dot horizontal direction. Yep. Dot horizontal direction, and if it's equal to directions dot left, then you're going to switch you over to directions dot right. Otherwise, directions dot left, and then we'll pass in this new direction. And if it's never specified, then it should be okay. Let's see. Nope, I've messed up something. Look at me. Terrible. Oh, that's because I forgot to add in something. Types.js. I think that's it. All right, so, and I miss. Oops, nope. Let's see if we can hit it now. No, but I mean, it's better. It's better? And I say that with like kindness, new direction. So when we do centipede, new centipede, custom direction, and then you get a custom direction, push in the centipede, new custom direction, water, and then if custom direction is set, then use it. Or yeah, directions dot right. See if we can hit this thing. We can. But you're still not right. One more breakpoint. Yep, here. So let's play. Where did my mouse go? Oh, it's over here. Debugger. Play. So we're good. Fire. Hit. We sliced you. You're good. It's here. Right. Custom direction should be right. Play you. You're down here. So then when we come back up here, we grab you. Play. Let's right. And we keep going, which it should be fine. We have the horizontal direction, and we move the distance. Wait, something's wrong. I think I need to swap you around. No, this should be fine. Let's say if it's equal to horizontal right, then go left. Something's puzzling me. I don't think this should matter. It shouldn't. Right. And let's take out our debugger statement. Something is very wrong here. Well, not very wrong. Clearly, it's still, we're still going along pretty strong. Play. So let's try that again. Hit. I mean, you're getting rid of the piece. And you come back over here to game. And we put a breakpoint here. Oh. I sliced the wrong thing. No wonder. I sliced the wrong thing. I want to start at 0 and go to the end. I sliced the wrong damn way. Let me revisit this. JS. Remove element from array at index. That should be it. Oh, they suggest the splice. Oh. They suggest the splice rather than the slice. Yeah, let's do that instead. No wonder. Comma 1. Let's see if we can get a tune out of this trombone. Fire. Oh, I need 1 to go the other way. But I mean, it's kind of what we wanted. That's not quite right, though. Something's off. So hit 1. That deleted 2. So you're going a little too short. I am wrong. So let's calculate you again. You're only doing 9 pieces. So I was wrong before with this. So we have our centipede. When we create the pieces, we should go less than length. And now when we shoot you, nice. The only other thing we need to do is handle yeah, we need to handle, so let's try to hit you in the middle again. Nice. We need to handle it so that when they collide with each other. Well, alright. So we'll probably do that as the last thing. So we now have it so that it responds to bullets. The only thing it doesn't respond to is hitting the other centipedes. We need to put that on the upper level. Hand that on upper level, don't we? Because we only want the first piece. How do we know what the first piece is? I don't know how I want to handle that because they collide all the time. Don't they? No, I guess they don't. So But we don't want them to just kind of bounce around the screen either. How do we want to handle you? Did not survive hit. We, I guess, could put it so that this collision also handles another did not survive hit. We could just say collided. Collided with circular object. Object. And then we'll come back over here and say bullet object. And instead of if it hit the collided, handle bullet collisions, handle other centipede collision and other centipedes. Yeah. Do the same thing here. And it's not going to do anything, it's just going to bounce them off of each other. If no other centipedes or no, if it's only one centipede, we want to, if no other centipedes or other centipedes that length is equal to 1, there's nothing to do. Like don't bounce off of yourself. Thank you very much. But if there's another centipede, we'll loop through those. We want to see if those other pieces collided. Ooh, this is a pain. This is going to be tough. I think I think I'm going to pause there. I don't think it's also quite right. Yeah. So let's see what this looks like with more mushrooms. So let's create 40 of these guys. So fire. This isn't quite right. Yep. So, yep. Nice. You see. Let's see. That's all right. I think I gotta handle the collisions with the other centipedes, and then I need to handle the creation of the spider. I think Friday I'll try the spider. That'll be new logic, something to kind of try. I'm just not sure. I'm getting a little drained here trying to figure out all the collision pieces for this. So I'm going to probably call it a little early, like 10 minutes early. So I appreciate everyone who showed up, and thank you for coming to another live stream of me trying to build a game. I'll continue building this game and working on it on Friday and on Sunday, and then perhaps after this we'll try to make a couple other arcade games, but there's still quite a bit of work to be done for this. The centipedes need to collide and be able to handle that behavior. I need to handle the destruction of the ship. And the mushrooms are working. So, and I need to invent the logic that says once there's no more centipedes, you've won and you go to the next level. So we have the next level logic that has to be created. And when the next level happens, we need to regenerate all of the new mushrooms, so forth and so on. And I don't have what the logic should be for that just yet. And we need to decide when to... We actually should probably create some hard levels. I guess we could keep creating like more and more levels. So just like at one particular point, you get like 20 centipedes and so forth and so on, and have it be random. So I think that's part of the next phase. And I think before I move to that phase, I'm going to start working on swapping out the mushroom images. So let's swap out the mushroom images, I guess, is an easy task next week. And then swap out or create a ship. So, but Friday will be adding the spider so that it moves up, goes across, and we need to have it so that when the bugs, any of them, collide with the ship, it gets destroyed. So let's go ahead and leave the live stream there for now. Thank you again for turning in, and I appreciate your time. I hope everyone has a good evening and a good Thanksgiving. Thank you very much. Have a